Hello dearies, this is Miss Medina and another wonderful video. In this one we're going to talk about adding polynomials, and once again we're just continuing the notes. See? Adding polynomials. When you add polynomials, try to think about these following steps when you're adding them. Number one, get rid of the parentheses first, or ignore as necessary unless you really have to distribute, and we'll talk about that in the upcoming videos. Identify and combine your like terms you want to simplify, and then make sure your final answer is in standard form. You'll get used to doing that very quickly. So here we go. All right, A, whew, Lord have mercy. 4x squared plus 2x plus 8 in parentheses. So this polynomial plus that polynomial. All right, so when you're adding and there is the coefficient is an understood one, we can ignore the parentheses. So here we go. Ignore parentheses. If the number in front is an understood one. Like this. You see how there is, we usually say nothing, but I mean technically right here, you see how right here? That's an understood one. You see over here? That's an understood one. So technically, the parentheses are a non-barrier for us. So now let's find our like terms. All right, I see 4x squared and 8x squared are like terms. I see this 2x and that 3x are like terms. And this constant and this constant are like terms. Okay. I know you can do this in your brains, but once again, it's a teaching video. So when you look at this, I see the coefficients on the yellow ones are the 4 and the 8, and they're both positive. So in your brain, you're thinking a positive 4 and a positive 8. That's going to give me a positive 12. Right, so this is 12x squared. Then we're focusing on the blue ones, the blue terms. So there's a positive 2 and a positive 3. So that's going to be a positive 5. So that's plus 5x. Notice that the only thing we work with when we're adding and subtracting is the coefficients. The variables stay the same. Okay, it's when we multiply that we add those exponents. And then lastly, your constants is a positive 8 and a positive 1. All right, positive 9. Here you go. All right, so this is the answer. Let's see. So now we've identified combined like terms, and now make sure it's in standard form. How many terms do you see? I see 3 terms, right? This is the first term right here. This is the second term, and that's the third term. All right, so let's check the degree. 12x squared, x is the variable, 2 is the exponent, so this one is degree 2. 5x, x is the variable, and the exponent is 1. 9 is a constant, so the degree is 0. But look, it's already from highest to lowest degree, 2, 1, 0. Booyah, standard form. Okay, let's do this again. Once again, let's focus on those parentheses, but look, what's outside in front of those parentheses? It's an understood one, so we can ignore those parentheses. And over here, same thing, it's an understood one in between the plus sign and that parentheses. So we can ignore those parentheses as well. Yay! So now we just have to find our like terms. Let me see. Let's see this, negative 2x, single x. No, this one has x squared right here. And so let me just erase this right here. Let me see a constant, 5. That's not a, this one is a constant. So we have a a solo player right here. And because I can see that this x has an exponent of 2, I'm going to write that one first, because I'm thinking ahead. And then negative 2x and positive 6x, so my brain is thinking negative 2 plus 6. So positive 4, so this is plus 4x. Then the blue one's positive 5 and positive 9. So that's positive 14. All right, so now you have to think about the degree of each of these terms. So this is the first term, the second term, and the third term. You see why we learn things in the linear process that we do? Because we need all of those little pieces of information so that we can build a foundation. X is the variable, exponent is 2. So this is degree 2. For x is the variable, and so the degree is 1, and 14 is a constant, degree is 0. See, I told you I was thinking ahead. So it's already in standard form, and I'm not sure why I circled it, but it's already in standard form. Ah! My bad. I was distracted. All right, this one is already in standard form. Sorry, it happens. All right, now application problem, and yes, you will see these, so you need to start getting used to it. We're in algebra now, we're big kids. Application, find an expression that represents the perimeter of the house. Perimeter and area are going to become things, one of those things that they kind of, you're expected to know. So I'll make a printout giving you all the formulas for the perimeters and the areas of common shapes, okay? Perimeter is the sum of all the sides. The outside, like the periphery of the place. So what does it mean to find the perimeter? So we need to find the sum of the two rooftops, I guess, the two walls. I'm trying to make a straight line, and then this one, not the middle one, because that's on the inside. So we just want the outside. So we're looking, we know this one, but you'll notice that this one has a single hash mark right here. Well, guess what? That means this one is also 6x minus 4. Why this hash mark right here tells you that they have the same measurement. All right, and then we know this one. And this one has 2 hash marks. So that means this one also has the same measurement. Hash mark, what's a hash mark, Miss Medina? This is a hash mark. You see the double lines right here? That tells you that they have the same measurement. So if this is 12x plus 3, this one is also 12x plus 3. And then we have the bottom one right here. And that one is 14x plus 3. So to find the perimeter of the house, we need to add these polynomials. All right, and actually this might be a case where stacking them might be a little bit easier, since they all have x to the first power and a constant. So by stacking them, I mean something like this. I don't know if I'm going to have enough room if I start here. I'm just going to start over here. 6x minus 4 plus the 6x minus 4 again, right? Plus the 12x plus 3. And then the 12x plus 3 again. And the 14x plus 14. 13. And see, so now it's a little bit easier. So you just need to think about these. Holy, Lord and guacamole. 6 and 6 is 12. 12 and 12 is 24. And then 14, 8, 10, 50. So this is 50x. And now the constants. I have a different color highlighter. Look at all of these colors. You can't see them. I'm sorry. Sure, I have other highlighters. Look at this purple, pink, purple. They look pretty much the same, right? I'm sorry. So sorry. And then, so you just put it in your calculator. -4, -4 is -8. 3 and 3 is +6. And then we have a 13. Right, and this is +19. So what is that, 11? And please double check me in the calculator and let me know if I did it correctly. I know it looks like a 7. I don't like ones. Real. Erase. There. And it's already in standard form. Beautiful. Subtracting is next.